Alright, so in this video, you guys will be describing transformations of functions from equations, and you will have to write equations from the graphs of functions using our transformation rules. We have three transformations that we're going to talk about. We have translations, which are movements of the graphs up, down, left, or right. These are the two new ones. Reflection, which is a flip of a graph over a line of reflection. You guys are used to flipping or reflecting over the y-axis. We're also going to talk about the x-axis. And dilation, which is a compression or stretch of a graph. This is like with quadratics when we make them wider or more narrow. We're stretching or compressing them. Alright, so essential question for today is, what is the difference between the equations when a graph has been horizontally or vertically transformed? So you should be able to answer where the operation is when we're horizontally or vertically transforming and what it means. So with transformation rules, we have 4 of them. We're going to first talk about the vertical transformation rules, which you guys are kind of used to. So a vertical transformation of f of x plus, we'll say a. We'll just call it a. So f of x plus a, this is a movement up. The plus outside of these parentheses, which I'm going to show you here in a little bit how important those are, means that we're vertical and we're going up. So vertical, you see, and it makes sense. F of x minus a is a translation down. So we're doing a vertical translation down. We got 2 others, f of x plus a, where now the plus a is inside the parentheses, is weird because you would think plus is going right, but this is actually going to go left. Okay? And then f of x minus a, where the minus a is inside, this one is our transformation or our translation going right. So these here, I forgot to label those, but these are our vertical. These here are horizontal. Okay, so describe each transformation from its parent function. So we talked about parent functions yesterday. We have that flip chart that we made together. So if we look at this one, g of x equals the absolute value of x plus 2. This plus 2 is outside, so that is a translation up 2. Okay, if we look at b, g of x is equal to the absolute value of x plus 3, where now plus 3 is on the inside. So if we look at our inside, plus a means left, so plus 3 means that it's a translation left 3. Okay, so g of x equals x squared minus 4. If you compare to d, you see how I added the parentheses. There's no parentheses here. So that minus 4 is our outside down vertical. So translation down 4. Now this minus 2 inside, minus on the inside, is right. So this is a translation down. Oh, sorry, not down. Whoa, what am I doing? It's not down. It is a translation right 2. All right, so let's check out our next ones. All right, so reflection rules. We have 2 reflection rules. We have negative f of x, which is a reflection Okay, so it is a reflection over the y-axis. And then we have f of negative x, where it is a reflection over the x-axis. So outside y, inside x. So if we come over here, g of x is equal to negative the absolute value of x squared. So in this case, what we have is we have a reflection over the y-axis because it is outside that absolute value. Over here, the negative is inside, so this is a reflection over the x-axis. All right, dilation rules. This one gets a little sketchy as well. So we have vertical again. Just like with the translations, vertical is outside. Okay? So if I have b f of x, right? This is a stretch vertically. If I have 1 over b f of x, then that is a compression vertically. All right, the horizontal switches it a little bit. So the rules are very similar. However, like I said, it switches it. So what is a stretch vertically is actually a compression horizontally. So if I have f of bx, this is a compression horizontally. And if I have f of 1 over bx, that is a stretch horizontally. All right, so if we look here, 2x squared, that's outside. There's no parentheses here, so it's considered outside. It's not a fraction, so it is a stretch, and not a fraction by it is greater than 1, is a stretch vertically. So this is a stretch vertically. All right, g of x equals 1, the absolute value of 1/3 x. So this one, the 1/3 right there, inside, is a stretch horizontally. So this one is a stretch horizontally. All right, so we can use these rules that we've gone over here to be able to write an equation. So it says, which equation best describes the graph to the right? Well, the shape of the graph is a parabola, which means that it is quadratic, which means it deals with x squared, right? So from this graph, remember x squared has a graph that looks like this. That's the parent function of the x squared. So what happened? We reflected over the y-axis, right? Because the parent function opens up, this one opens down. If you look at the vertex, it went up, because this is 2, it went up 2. So up 2. And this spot right here looks like it's in the middle of 0 and -1, so it went left 1. Okay, so that's inside. That and that are outside. All right, so g of x should have a negative outside. Going left, if we go back to our transformations or translations, inside going left is a plus. So we should have x plus, we went 1 spot, and then we went up, outside is also plus for going up, so we should have and this is squared, so we should have negative x plus 1 squared plus 2. So negative x minus, not good. Negative x plus 1 squared, good. Minus 2, not good. Negative x minus 1, not good. So it looks like it's D. Negative x plus 1 squared plus 2. D is the correct answer for this. All right, I know you guys are going to have questions. I will be coming around the room. Ask them as you get them, please. All right, and then go ahead and complete the problem set, and we will work through this as best we can. All right.